All right, Stefan, thank you very much for taking your time here at the Smarter E Power to Drive and EES conference. We want to talk about BMS and battery innovation. But before we jump into today's topic, how did you find into the field of battery innovation?
Yeah, well, thank you for having me. Basically, I've been working in the battery industry for more than 16 years now. When I graduated from college, I wanted to do something really innovative, something new, and as things always are in life, but by chance a bit and
Mm-hmm.
by coincidence, I ended up my first job working on the BMS of the first lithium-ion battery pack in a hybrid vehicle that was launched in Germany.
Mm-hmm.
Was the early 2010s or late 2000s, and yeah, ever since then I somehow stuck with the battery industry.
Well, so when did you enter Munich Electrification, or when did the Munich Electrification your journey there started?
Yes, we started the company in early 2015. I'm one of the three founders, actually. And back then, I was actually quite interested in starting a company that combines Silicon Valley spirit, because that was right after my time in California, where I worked for Tesla and had really great exposure to technology and to innovation. And we wanted to conserve some of that innovation spirit and bring it to Europe.
Cool, yeah.
So we started this company early 2015 with three guys. Yeah.
Must be have quite exciting times to work during that time over there, right? Because I think this was really the ramp up
Yeah.
phase at Tesla back then.
Yeah, it was great fun. I mean, I was very young back then, and I have a degree of the University of Applied Sciences, basically, and I went over there, and all my colleagues were from Stanford, MIT, and I was like, okay, how can I even work with these people? Because I was back then very interested in academia and felt a bit underqualified. But in fact, it was a really great experience to work with these guys and to work on a practical problem at fast pace. And
Mm.
I had really a great time there, successful time as well. And actually, I worked crazy hours for sure, weekends, and one time was 24/7, 24 hours in a row. That was really fun. But it wasn't even back then. It was a very positive atmosphere. We were all
Okay,
friends. We were all fighting for the same cause. It was really, really fascinating. It was really good. Yeah.
interesting. Wow. But then there was the decision to start your own thing and take that spirit to Munich and start your own business. So can you
Yeah.
explain how that unfolded and how you then entered the field of battery management systems?
Yeah, I mean, basically, when I was at Tesla, I was one of three guys working on the BMS for basically all of the projects. Great colleagues. It was a great learning experience.
Mm.
And then I came back after 2 years to Europe for actually back then private reasons, and I started working for BMW back then. And that was also fun, but also a bit of a cultural shock because in the early 2010s, I mean, the approach was so radically different. I mean, just thinking about how you approach software development, how you approach, development speed, software cycles, all of that was very different.
Yeah.
And also back then, we were working with suppliers, BMS suppliers. And before that, I was basically working with my colleagues, and we had a lot of it in-house, basically.
Hmm.
And back then, I was a bit. I had the idea, like, okay, if these guys work with suppliers, which is great, I think we can do it better. We were not quite satisfied with the
Wow.
attitude, because many of the suppliers were like, yeah, give me the specification, I will make an electronic board for you, but not really thinking from how can we make a great battery that makes a great electric car. Like, really think for yourself a little bit. How can we push the limits? How can we make it better?
Hmm.
And also, how can we be fast and reliable? And I found a big gap between what I was used to and what I saw.
Hmm.
And yeah, basically, long story short, we wanted to then start Munich Electrification to become a better BMS supplier,
Cool.
and to really serve our customers with a great product.
So if you should pinpoint it to one, two, three, or four sentences, what is Munich Electrification's innovation that really stands out?
So we are a provider of highly integrated, sophisticated battery management systems that have really good software architecture, great SOX algorithms, and combine that with a smart system integration thought. So, for example, reducing number of cables, reducing number of components, and integrating well into the battery pack.
Okay. Considering the whole landscape of e-mobility at the moment and the developments, I mean, there are big differences between the global development and the German landscape right now. If you should point out a couple of challenges that you see that are unsolved yet, that you can solve, or that generally have to be solved, which one would you name?
Yeah, I mean there are quite a few. I mean, honestly, it's about cost efficiency and reliability. That sounds boring, but it's certainly on the agenda to make
Can you
sure.
explain, especially reliability in the sense, like, what do you mean?
Yeah.
Like from a safety point of view, from an, yeah, just
So basically, we are at the beginning of a ramp up, especially in the field where we are very active in is commercial vehicle. We also do passenger car and stationary, but in this field, the sales numbers are not that big at the moment. I mean, we talk about a couple of thousands of trucks today, but we also see a huge growth. And what's important for an electric truck is that it has a maximum uptime. It has to work all the time.
yes.
And how should I put it? I think some of the BMS chips and some of the BMS technology has to be applied very well in commercial vehicle industry to make it robust. One example is surge robustness. We know exactly that a 800 volt, 1000 volt truck will have a very harsh environment in terms of electrical surges and electrical spikes on the power net. And this is something we've been working very hard on for a lot of years now to make the BMS as robust as possible. And we see that something which is not really well explored yet. I mean, we don't find so many standards how to make a BMS as robust as it possibly can be against overvoltages and surges. And that's something.
Can you explain that for those who don't know?
Sure.
What this means in technical terms? I think this is worth explaining.
So basically, a battery cell has whatever between 2.5 and 4.2 volt, mostly if it's NMC maybe. And then you think about what is the acceptable range of voltage that we have to prepare the BMS for. We can argue, okay, 2.5, 4.2. Let's make it 0 to 5. 0 to 5 volt, we will not see any other voltage, right? And then you dimension your BMS. Let's say you have 10 cells. So you say, okay, 10 times 5, 50 volt. That's the maximum we'll see. And then you test it and it works fine and you're happy.
Yes.
But then when you put it in the truck and you do specific things like high voltage precharge where you energize the DC bus, or you connect a garbage press as an electric load or something specific, you will see that the voltage range will be exceeded. There will be pulses and surges. Basically, you will see 5, 6, 7, 8 volt for a few microseconds. You might even see negative voltages, and the BMS has to be robust against that. The BMS has to be tested and has to be protected to survive that. And the bad thing is, this doesn't necessarily happen every time. Maybe happens every 100th time you operate the battery.
Okay.
Depends on the vehicle architecture and the load. And this is something where BMSs, like everybody can do a BMS. You copy a reference design, plug it in, okay, it works. But to make sure it works all the time, to make sure it's robust enough, I think that's a huge technical challenge.
All right.
Yeah.
Okay. Understand.
Yeah.
Do you think it's solvable?
Yeah, absolutely. I mean, we have a very good relationship with our silicon providers. I mean, the IC manufacturers, the big companies there. We have a close partnership for many years with them, and we innovate together. So we design new test fixtures, new test procedures, and we actively work on the next generation of silicon and the present generation as well to make sure we are robust and we have a good product. Yeah.
Right.
Yeah.
So if you should pinpoint out a couple of prime examples on the potential that is out there. You just mentioned the cooperation that you build up.
Yeah.
This expedition is meant to support the European battery ecosystem.
Yeah.
To really build an autonomous economy in that regard, an industry. Considering that, what is our potential and your contribution to that?
I mean, there's a lot of potential in the market for commercial vehicle and also stationary storage. I mean, I think those two are quite different. The stationary storage market is already ramping up a lot. We saw from 96 gigawatt hours of stationary batteries in 2023, it ramped up to 160 gigawatt hours in 2024. It's dramatically increasing already. whereas the truck industry is still at the bottom of the hockey stick. It's just coming. And the potentials are really to execute well, basically to get the batteries out to the market, because the need is there, demand is there, and to make sure that we execute it well. I mean, I already mentioned reliability.
Yes.
Another thing is cost. We have to make sure that we are competitive in the European ecosystem. We have to have smart solutions. To just give you one example, we used to have CAN bus communication inside the battery pack for the different cell monitoring boards. And CAN bus is great, it's very robust, but it's not the cost-efficient solution. You want to reduce the number of microcontrollers. You want to reduce the money you spend on the bill of material to have a really cost-efficient battery pack. Along those lines, there are many things we can do to really, look at the battery, look at the bill of material, and try to make it cost-efficient and robust at the same time.
Can that, all what you explained, solve those puzzles? Can that be European driven, or do you think we rely on the global competence, especially Asia?
That's a very good question. I think on the BMS and silicon side, we can absolutely do this in Europe. We have European suppliers. We have European technology. And for example, our production is in Eastern Europe, so we have already a quite Eurocentric product. Of course, we are also making use of US chip manufacturers and their technology, which is great.
Okay.
But we are not really relying too much on China in the electronics side. Very different from the cell perspective, I would say. I think there's a good ecosystem in Europe and the US for BMS.
All right.
Yeah.
Cool. That's really promising information there.
Yeah.
If you would have one wish, one advice for industry they would like to give, one call to action, what would it be?
My call to action is that specifically on the BMS, I aim for the highest cybersecurity and safety standards. Let's try to do a good job there. Lead by example. Try to do a product which is more secure and more safe, and not don't shoot for the lowest cost solution necessarily if it compromises reliability, safety, and security.
All right, Stefan. Thank you very much. Looking forward to the next conversation and potentially visit along the route on the battery expedition at Munich Electrification.
Thank you very much, Simon.